Hello everyone, welcome. Can you hear me? Hello. Hello, can you hear me?
Yes, I can hear you.
Okay, thank you. Good afternoon. Yeah, good afternoon. Okay, just waiting 1 minute, then we'll start. Yes, I face some technical issue from my side. So I try to use join another link. We said that's why. So now I find out the proper link, then join. Okay, just we're waiting 1 minute, then we'll start. Okay, so we will start with this session. Okay, so first of all, welcome. Welcome to the another advanced online training program on research-based online training program. Okay, so in this, I hope I already completed my beginners course for 7 days. We already know about that. Okay, okay. So you already know about the some basic function of Google Earth Engine. Okay, how it will work. So it's not the beginners course. So we are just start the application. Okay, different types of remote sensing application, and this application may be research based. Okay, so we try to follow different types of scientific paper and then further we try to apply or adopt this type of model using the code. Okay, and we try to suppose every section or every content we try to publish the scientific paper. Okay, so in this case you can easily choose your own study area. So after completing the session, suppose today I talk about that one topic, suppose Rusli model or other model, so you try to implement this type of model for your own study area, and further you try to publish the scientific paper. Okay, so this is our main goal, to publish the scientific paper is content. Okay, every content we try to publish and make the analysis. Okay, so first of all I try to discuss about our full course syllabus in the research based program. Okay, so which type or topic we try to cover. So let me share my screen, just a minute. Okay, can you see my screen? Is it visible? Can you see my screen now? Yeah.
Not yet.
Is it visible now? Can you see my screen now?
No, it's just showing your name, not yet displayed anything.
Why? Okay, just a minute. So anyone face this same problem?
I am seeing the screen. I can see the screen.
Yeah.
No, I am seeing the screen. I can see it.
Okay, so kindly you refresh your tab, then I hope it also okay. So I it also shared. Okay, I already shared my screen, and I also see it my another laptop. I also find out the screen. No problem. Yeah. Okay, so we continue. Yeah. So basically, this is our research-based training on GIS remote sensing with Google Earth Engine. So not only for the Google Earth Engine, we also help some other geospatial tool also, such as ArcMap or QGIS. We also take this type of help for the different types of analysis. Not all of using only for the Google Earth Engine, because all of analysis is not possible to use the Google Earth Engine. So we also learn some other tool also, such as QGIS, also ArcGIS or ArcMap. So this type of tool we also integrate with the Google Earth Engine and also complete our all of topic. Okay. So basically, this is our total 14 days online training program. So each day, basically one day a week, we take the class. So for the Monday, okay, we take the class for this time. Okay, every day we try to meet the same time. Okay, no problem. And if you check this course content, so first of all, okay, so in this case, we try to add all of research-based content or research-based program. Suppose first time we discuss about the Rusli model for erosion risk mapping, how we can easily apply the Rusli model and how we can easily calculate the annual soil loss for any study area. Okay, for any study area, and how we can easily adapt our model. We also discuss about that. And if you check lot of paper only for the Rusli model, they use the Rusli model for soil loss estimation using the Rusli model and publish a lot of scientific paper we can easily publish. As well as we also discuss about the vegetation change detection. Okay, how we can easily use the suppose 20 years or more than 20 years, so historical data analysis. Okay, so how vegetation change year by year. So a lot of paper is available. So I also send you some reference paper also for every topic. So you also try, after completing the session, you also try to read this type of paper, then you can also increase your knowledge about this type of topic. Okay, and also discuss about the rainfall pattern analysis, so monthly, seasonal or annual. Then we talk about the land use land cover classification using machine learning. So I here all of you already complete my 7 days online training program, so I also discuss this topic also. But in this case, we also try to add the some other extra advanced topic for the machine learning. In this section we try to add, and then we try to make the land use land cover classification, and our main focus is the urban expansion. Okay, so how we can easily make the urban expansion, and lot of paper already published for the urban expansion or urban heat island or urban thermal field variance index. So we just simply combine, okay, suppose urban heat island or urban thermal field variance index or urban expansion. So this type of thing we also combine. Then LST and DVI time series chart for urban heat island. Okay, we try to identify for vegetation health and temperature trend for the urban versus rural zone area. We also try to identify. And satellite based aridity index, this is the one kind of drought assessment index. So how we can easily apply the aridity index and monitor the drought, we also discuss about that. Then LST monitoring using Landsat satellite imagery for the historical and identify for the hot spot for increasing the LST. We also discuss about that, as well as also linear regression and trend analysis, different types of climatic variable or bioclimate variable. So we also discuss about that. And also man candle and DVI trend analysis, how we can easily apply the man candle and project that detect the long-term greening and burning trends on the semi-arid region. Okay, and also VCI, TCI, VSI. So this type of index help you mainly working with drought monitoring. Okay, and also deforestation using machine learning, how we can get the deforestation using machine learning, such as illegal logging area, how we can easily detect using the different types of satellite images. We also discuss about that. And deforestation and agroforestation, we also discuss about that. And slope classification or area calculation, NDVI classification, raster restriction, and monitoring bioclimatic variable. Then it's lot of topic we try to discuss. Monthly evapotranspiration monitoring, and this type of topic we try to connect a paper. We try to connect a single scientific paper. Okay, so how to use the evapotranspiration, how I can use this evapotranspiration data and make a scientific paper. So that's why every content I will try to give you some reference scientific article, so then you can easily get the idea. This is the evapotranspiration, I can easily use it, and then further I make the analysis and publish the scientific paper. Okay, then soil salinity mapping, how we can easily do. okay, soil salinity mapping, and landslide susceptibility mapping. Okay, there are a lot of paper is available for the landslide using the different method, and flood mapping. There are a lot of paper. So in the 7 days previous 7 days training, I discussed about the flood mapping, but not talk about the flood damage assessment. Okay, so I can find out a lot of paper. They are only work for the damage assessment. Suppose how much cropland area is destroyed, or how much urban is destroyed for the flood. So this type of assessment we also discuss about in this section for flood mapping and damage assessment. And also we try to monitor the crop health using the agriculture productivity over a period of time, or agricultural land suitability analysis. Look, there are a lot of suitability we can easily do, but I tried, suppose I have a specific boundary. So in this boundary I want to find out which place have the more appropriate for the agricultural land. Okay, this type of things we also discuss. And same as livestock suitability. Okay, so there are a lot of paper you can easily find out the agricultural land suitability, livestock suitability, or this is very important for the future land use land cover prediction. Okay, we also try to discuss about that. Suppose I have the different years land use land cover classification map. So now I just simply add different types of independent and dependent variable. Further we try to apply the model, and then we predict the land use land cover classification for the future, as well as how we can also, using the same process, we can also predict for LST. Okay, for the future LST, or also urban thermal preference index. Okay, this type of things I'll try to discuss inshallah in this section. And barrel and build up mapping. Okay, how we can easily use. And finally flood risk mapping. So this is our first batch, so that's why I try to add this type of topic. Further, if I find out more interesting topic, then I also try to including in this section. And this is our first batch in this. So every, suppose if I update my course syllabus for the future, then this type of material you also get the freely all time. Okay, if I update this material, suppose in the future I also add some new content or new topic in this syllabus, then all of you, because you already enroll this course, so all of you can easily get the this type of topic and get the freely. Okay, if I just add the more advanced topic future, okay, then you can easily get the freely all of content. And I can easily upload all of content in our Google Classroom. When I update this type of content, this material I can easily upload in our Google Classroom, then you can easily access from here. Okay, so let me share my okay, let me open my slide. Okay, so let's go ahead and discuss one by one all of topic, then you can easily get the idea. So every day I try to complete the 2 topics, because here we find out the more than 30 topics. So if I just complete the every day, suppose 2 topic per day, then I hope it will be completed the 14 days. It will be completed the full syllabus. Okay. So today I discuss about that Rusli model for erosion risk mapping, and also discuss about the NDVI change detection for forest degradation monitoring. Okay. So these 2 topics I try to discuss one by one, then you can easily get the idea. So first of all, we try to check some scientific paper about this type of topic. So let's go. So you can simply search your paper. Suppose, okay, let me check. So this is the one kind of paper, yeah. So this is the paper for NDVI drape vegetation trend and driving factors in West African, this region. So in this paper, basically they are identify for vegetation trend, okay, and they are apply the model. It's called the man candles, okay, monotonic trend test. They are apply, and then they are identify for vegetation dynamics, okay, and further non-parametric and there you said the okay. So I also send this type of paper also. Try to read, then get the more better idea. So now suppose I want to apply this man candle test on my vegetation. So how I can do using Google Earth Engine and follow this type of material. So okay, so let me open my code editor. And when you face any question or any conflict, simply ask me. I try to give the answer all time, no problem. Okay, so first of all, let us discuss about the vegetation trend analysis. Okay. Okay. So first of all, we need to set our time period. Okay, suppose how much time you want to use for the vegetation trend analysis. Suppose I want to 982, suppose 2025 or 990 to 2025. Okay, so I want to use this data set from 990 to 2025 and make the vegetation trend analysis. Okay, so for that, first of all, what I need? So first of all, I need the image collection. Okay, I need the image collection from 990 to 2025. Okay, all of image I need for annual image collection. So how I can take the image collection? So in this case, we need to merge different Landsat satellite images. Suppose I need to merge Landsat 5, I need to merge Landsat 7, then Landsat 8 and Landsat 9. Okay, and then we can easily create the annual image collection from 1990 to 2025. Okay, so first of all, we need to create the image collection, and it's very important because when you work with historical data analysis, you need this type of annual image collection, not only for the vegetation trend. Suppose you want to make the LST monitoring from 1990 to 2025, then you need to create the image collection for annual image collection. Suppose you want to make the land use land cover classification, so then you also need to create the image collection from 1990 to 2025. So first of all, we discuss about that how we can easily create the image collection from 1990 to 2025. Then we discuss about the vegetation trend, how we can easily make the trend between this time period using the man candle test. So first of all, we simply import our study area, which area you want to work. Suppose in this case, I just choose one study area. Suppose, okay, let me open from asset tab. So I work with the mangrove forest, Sundarbans. So I simply import, and in the Sundarban mangrove forest, I want to identify vegetation trend analysis from 1990 to 2025. Okay, between this time period. So first of all, I need the annual image collection between this time period. So I simply choose my study area. I put the name, suppose AOI. And then I want to visualize my study area. So simple, just right here map dot add layer and display the AOI, and also focus the given study area map dot center object. Oh, sorry, center object is AOI, zoom level was 10, and run the code. So now we find out this is my study area. So for this study area, I want to monitor vegetation trend between this time period. So first of all, I need the image collection between this time period 1990 to 2025. So now first of all, I need to merge Landsat 5, 7, 8 and 9. Okay, all of image collection I simply merge for my study area. And if you check the Landsat 5, 7, 8, 9 have a common difference on their bands. So if you check, click on the browse data catalog and check the data set from Landsat. If you check, suppose Landsat 8 and 9, these two satellite images is the similar band combination. If you check, suppose Landsat 8, we try to use surface reflectance. And if you check the bands, you can see SRB1, SRB2, SRB3. SRB1 is the coastal aerosol. SRB2 is the blue, then green, red, near infrared. Okay, and same sequence we also find out in the Landsat 9. Okay, just check the Landsat 9. Surface reflectance. And then check the SRB1 is the coastal aerosol. Okay, then blue, green, red, near infrared. So Landsat 8 and 9 are the similar sequence for the bands, but Landsat 7 is the different. If you check the Landsat 7, suppose Landsat 7 surface reflectance, we find out that you can see SRB1 is the blue band. Okay, so there is no coastal aerosol. SRB2 is the green band. SRB3 is the red band. So it's the another sequence. And if you check the Landsat 5, Landsat 5 and 7 are the similar sequence. If you check Landsat 5 surface reflectance, we find out the SRB1 is the blue, SRB2 is the green, red. So from here you can get the idea Landsat 5 and 7 are the similar band combination, and also Landsat 8 and 9 are the similar. But when I combine, suppose I want to combine Landsat 5, 7, 8 and 9, then I need to make the same sequence, all of bands. Okay, so first of all I need to make the same sequence, because in this case I want to combine all of satellite images, Landsat 5, 7, 8, 9. But Landsat 5 and 7 similar, but Landsat 8 and 9 it's different. But when you merge Landsat 5, 7, 8, 9, you create the same sequence. Suppose B1 is the blue, B2 is the red, B3 is the green. Similar sequence, all of bands, because in this case I just simply merge all of image collection. So how I can make this similar sequence of band, all of image collection? So let's go ahead and discuss about that. So for that you can simply take a variable. Suppose I put the variable name is Landsat 5 bands. So this variable I simply write all of, store it. I just make a list and store it all of bands, and simply I take the another variable, suppose Landsat 7 bands. So in this variable I just simply store it all of bands of Landsat 7. Okay, and Landsat 5 and 7 are the similar, so I can simply write together, no problem. Suppose just I put here first band is the SRB1. Okay, then put the second band is the SRB2, then third band SRB3. Okay, be similar band, I simply write SRB4. Okay, and then I find out SRB5. Okay, and 6 is not available. Landsat 5 and 7 there is no band about the band 6, so we try to put here the SRB7. Okay, so we simply create Landsat 5 and 7, just put the Landsat band. So now I take the another variable. Suppose I put the variable name is the L5 names. Okay, L5 names. Okay, and also create the another variable in here, L7 names. So just I put the name, to take a variable L7 names and just store it, the bands. So at the same time I simply write the band name, because similar band name. So first SRB1, it's called the blue band. I put the blue. Then SRB2, it's called the green band. So I put here the green. Then SRB3, it's called the red band. Then SRB4, it's the near infrared band. SRB5, it's a short wave infrared 1 band. And SRB7, it's short wave infrared 2 band. So now Landsat 7 and Landsat 5 is done. I simply write the band name. So now we talk about the Landsat 8 and 9. So for the Landsat 8 and 9, so take a variable. Suppose I put the variable name is the L8 bands equal, and same take the another variable L9 bands equal, and I put the name. Okay, just put the band name for the Landsat 8 and 9 because similar band name I write the same at the same time. I simply write, suppose Landsat 8, I put the band name is that SRB2. In this case, you can see we simply skip one band. I skip the one band which is coastal aerosol because coastal aerosol is not available in my Landsat 5 and 7. But when I merge all of satellite image collection, I keep the same sequence, all of bands name. Okay, so for that I simply skip SRB1. So I start from SRB2. Then I put here SRB3. Then put here SRB4. Then SRB5. Okay, and also SRB6 because Landsat 8 and 9 SRB6 is available, and finally SRB7. So now just put the band name. So take a variable L8 names equal, and also take the another variable, suppose L9 names equal. So now define, so write at the same time. So just right here SRB2 is the blue. Okay, SRB3 is the green, SRB4 is the red, SRB5 is the near infrared, SRB6 is the short wave infrared 1, SRB7 is that short wave infrared 2. So now if you check all of bands, this line is the similar. Okay, you can say SR blue, green, red, near infrared, short wave. So Landsat 5, 7, 8 and 9, all the bands are similar. So now we can easily combine. Okay, so this is the first step. When you combine Landsat 5, 7, 8, 9, then we just keep the same sequence of band name. So in this case, blue, green, red, near infrared, short wave infrared 1, short wave infrared 2. I just put same sequence, all of bands name. Okay, so after completing these things, we just simply take our collection. Suppose I just take the collection for Landsat 9. First of all, I take the collection from Landsat 9. So same, just call the Landsat 9. I want to work surface reflectance. Just copy the snippet ID. Okay, and we already know about that, how we can easily filtering this type of Landsat image collection. I just put the same process. Take a variable, I put the variable suppose L9 and then paste here, and simply filtering. We already know about that filter bounds function, how it will be worked. So filter bounds with our study area which is AOI. Okay, then put the filter date. Okay, so now I simply take the date from here. Suppose I take that whole time period. Okay, 2021 1031 to whole time period. I simply choose this is my start, and end I put the last time period 2025 0904. Just I copy and paste here. and then also put the filter metadata for filtering image property. So in this case we choose suppose cloud cover, and cloud, I just put the cloud cover. I put suppose cloud cover less than. So in this case, suppose when I put the less than 1, it creates some problem. This problem is that some year there is no image less than 1%. So then we find out the 0. Okay, it shows the 0. Suppose in year 1995 there is no image less than 1% for my study area, then it show a problem. It show the problem is that round figure 0, there is no image because less than 1% image is not available. So how I can handle this problem? So for that, you can simply increase the cloud level. Suppose I simply put the increase the cloud level less than 60, okay, or less than 80. Okay, so now what happened? So now between this time period, less than 18, all of images stored in my collection in this variable storage. But when I increase the cloud level, some cloudy pixel appeared in my satellite images. So now this cloud I need to remove. So in the 7 days class, I also discussed about the cloud remover function. So how we can easily create the cloud remover function, and this function help you to remove the cloud. So this technique now we are using here, and further if I increase the cloud level and also apply the cloud remover function, then this cloud is not appeared in my satellite images. Okay, so this is the one way. Suppose now we need to create the cloud remover function, and this remover function we simply connect with the Landsat 9, Landsat 8, Landsat 7, and Landsat 5. Okay, so all of image collection is simply connect. So first of all, I simply create the collection. So just I create the another collection. Suppose now I create the collection for Landsat 8. So just change it. Suppose L8. L8, and I put the call the Landsat 8 image collection. So just click on here, back, and go to the Landsat 8. So click on the Landsat 8, and if you click on the surface reflectance for the Landsat 8, just copy the snippet ID of the Landsat 8 and paste here. Okay, so now also change the time period. This is the time period 2013-03-18 to present time. Just paste here, and also you can see this is the time 2025-08-31. Okay, just I copy and paste here. Okay, and keep the less than 80% cloud cover. And finally, we also take the another, suppose Landsat 7 collection. Just I copy the same line of code, and this code we try to add with the Landsat 7. So put the L7, okay, and call the Landsat 7 image collection. So same process, just open the Landsat 7 and click on the surface reflectance, copy the snippet ID and change it. So now also change the time period. Suppose I put the time period, this is the time period, start time. And this is the end time. Pasted. So now copy it again. So now we take the final image collection for Landsat 5. If you want, you can also merge the Landsat 4 or 1 to 5. Easy, same process. So now I just take the another variable, suppose L5. Now just copy the snippet ID from the Landsat 5. Landsat 5 surface reflectance. Copy this ID and then change it snippet ID for Landsat 5. Okay, so now I put the time period from here. So this is my time period. It's available from 1984. 1984. I just paste here, and also 2012. And paste here. Okay, so now if you check, we simply import Landsat 897, as well as we also need to import the another thing, our bands. Okay, you can see I already put the bands and band name. So just put here dot select function and put the Landsat 9 bands comma Landsat names. Okay, so now when I just put the sequence this way, so it take the last sequence, blue, green, red, near infrared, short wave. So it take the last sequence. So when I check the band name, so band name show blue, green, red, near infrared, not show the number B2, B3 not showing. Same process also apply for Landsat 8. Just I copy the same line of code and paste here, and I put it's a Landsat 8 band names and Landsat 8 names. Okay, then put the another for the Landsat 7. So put the L7 bands and L7 names. So same process for the Landsat 5. Just paste here. So put here the L5 bands and L5 names. Okay, so now we simply put the collection, but in this collection we put the less than 18% cloud. So when I display the image, we find out the some cloud. So now we create a cloud remover function. So this cloud remover function help me to remove all of cloud, okay, from my satellite images. Even if I increase the cloud level, suppose 80%, 90%, even 100% someplace, that there is no problem. But if I put the 1%, suppose for my study area less than 1% image is not available for the any specific year, then it shows the 0. So further we try to keep the suppose 60% or 50% or 80%, and further we are just applying the cloud remover function. So then this type of cloud is not displayed in my imagery. We find out very neat and clean satellite imagery. And if you check all of image collection, Landsat 5, 7, 8, 9 have the similar band name for cloud remover. If you check, this band name is the QA pixel. If you check the band name, it's called the QA pixel. Okay, QA pixel. So this is a similar band and similar bit cloud and cloud shadow, bit 3 and bit 4. Landsat 5, Landsat 7, Landsat 8, Landsat 9, all image collection are the similar. So in this case, if I create a function and further this function, if I simply connect with my image collection, all of image collection, same function, then it will be okay. Because all bands, all image collection, Landsat 5, then if you check suppose Landsat 7, Landsat 8, Landsat 9, all image collection are the similar band name and similar bit number. Suppose Landsat 8, check, we find out the similar band name and similar bit number. So that's why it easily work. Okay, you can see the QA pixel and you can see bit 3 and bit 4. Okay, bit number is similar. So now I create a one function. This function I simply connect Landsat 9, Landsat 8, Landsat 7 and Landsat 5. Then it's easily remove all of cloud and we find out the very neat and clean satellite images for every year. So let's go try to create a function. So I create a function in here. Suppose I put the name is that cloud remover function. Suppose cloud remover. So take a variable and just copy the, this is the band, QA pixel. So in the 7 days beginners class, I also discussed about that, how we can easily work with the cloud remover function. Okay, so same things we are just apply. So take a variable, I put the variable name, suppose cloud remover. Okay, equal, create a function, I put the element name, suppose img, and then curly bracket. So in this curly bracket, I just put what I need using this element. So first of all, take a variable, suppose QA, you can put any name as a variable, and put the element name and select the band of QA pixel. Okay, and now this band have a 2-bit, bit 3 and bit 4. So you simply use the this 2-bit, bit 3 and bit 4. Suppose I just take a variable, sorry, so take the variable, suppose cloud shadow bit equal, put the bit number, cloud shadow bit number is the 4, just put the 4. Then take the another variable, suppose it's a cloud, so put the cloud bit, so 1 less than put the bit number, so bit number for 3. So we simply select the bit number 4 and 3. So for that, just take a variable, suppose max, and then this bit come from this band QA. Okay, this band basically stored in the QA. So I simply call the QA. So now this bit I want to connect with the bit 4 and bit 3. So put here the bit wise AND function. Yes, it also recorded. You can also get the recorded class also, no problem. So bitwise AND. So I simply call the bitwise AND because this band have a 2-bit, if you check. So this type of things we also discussed in the beginners class 7 days. So I can explain. Suppose again the QA pixel. So this the 2-bit, bit 3 and bit 4 I want to use, cloud and cloud shadow. So for the connecting, just use here the bitwise AND function. Yes, any question please? Any question please? Yeah. Any question or any confusion, you can ask me anytime. Please.
Sorry for interruption. It's no question. Is it video is recording?
Yes. Yeah, recorded. You can, after the completing the live session, all of you can easily access the recorded class from our Google Classroom. Not only for the video class, all of practice code, everything, every slide or reference paper you can easily get. So now this is the band QA pixel. So bitwise AND, I just connect with this bit. So just paste here and set equal to 0 signal. Basically every bit we find out the 2 signals, 0 and 1. 0 indicating about that there is no cloud, and then put here the AND function. So AND, call the QA connecting with another bit, bitwise AND. This bit number is this cloud bit, just copy and set equal to 0 signal, which is indicating about the clear condition. So now what I return from this function, so I want to return this image update max with this condition, and this condition is stored in this variable max. Just copy and paste here. So now it's a cloud remover function we generate. So this function we can simply connect all of image collection. So how I can connect? Just copy the function variable name and then connect. Just paste here dot map and paste here. Also dot map and paste here, and also just dot map. Just I connect the cloud remover function with all of image collection, Landsat 5, 7, 8 and 9. Just paste here. So now what happened? So now if I increase the cloud level, this cloud is not appeared in my satellite images because I apply the cloud remover function. Okay, so this is the one way we can simply remove all of cloud. And if you just simply merge, suppose now we simply merge. So take a variable, just I make the combine all of image collection together. So for that, take a variable, suppose I put the variable name with the full collection equal. So simply merge, suppose L9, then put here the merge function, put the L8, then it merge, then L7 merge, then L5. Okay, we simply merge the Landsat 9, 8, 7, and 5. And now I want to check how many image collection, okay, I have. So for that, just print this full collection and use the size function. So now it's computing how many images are available. Okay, we find out for our study area. So this is the total number of image collection. We find out 3,501 image collection. Okay, when I merge Landsat 9, Landsat 8, Landsat 7, and Landsat 5. Okay, suppose I just suppose I put the cloud level, I take suppose 50 or less than 50%. So first of all, we try lower cloud level. If I find out, suppose any year there is no image, suppose I find out 1 year it shows the 0 means that there is no image, then we try to increase the cloud level. Okay, otherwise not need. Suppose some year less than 1% is not available, then we just increase the cloud level. Some year suppose less than 10% is not available, then we simply increase. So now if you check how many images are available, so we find out that 2,809 images after make the combination Landsat 9, 8, 7, and 5. So this is my full image collection. Okay, we find out. But what is my target? My target is that I want to create the annual image collection from 1980 to 2025. Okay, annual image collection. And further, I want to check the vegetation trend analysis. Okay. So for annual image collection, we create a function. Suppose I create a function. So this function basically help you annually. Suppose 1990, it's find out suppose 5 images. So then just use the 5 images and create the median composite. Okay, suppose similar, suppose I find out the 1991, it find out suppose 4 images or 3 images. So these 3 images combine and create the median composite. Okay, so I create a function. So this function filter yearly. Suppose from 2,809 images, it filter yearly. Okay, suppose 1990, it's find out 5 images and create the median composite. 1991, it's find out the 3 images and create the median composite, and up to 2025. Okay, so now how I can filter? So I have a collection. So this collection I want to filter annually. So this is my target. I have a collection. This collection I want to filter into annual image collection. So for that, first of all, you need to define your observation time period. So let's go try to take a variable and define observation time period. So take a variable. Suppose I put the variable name is start year equal. So I define the time. Suppose it will be start from 1990. So this is my start year. Take the another variable. Suppose end year. I put the time. Suppose 2025. Okay, so I define my observation time. This observation time, every year I need images from this collection, and further I create the median composite. So this is my final argument, and these things I just create a function. Okay, for this I create a function. This function filter this image collection every year between the time period. Okay, and create the median function. Okay, suppose this is the image collection. Okay, so this is the image collection 2,809. Okay, these images or this image collection you want to convert into we find out that how much year? 36 years. Yeah, 36 years. Okay, so this 2,809 image collection I want to convert into 36 years between 1990 to 2025. Okay, so this is my ultimate goal. So I have this image collection. This image collection I will convert into total 36 years. To 36 years image collection. So how I can do it? So for that we use a function. This function called, I will just show you the function from the docs tab. EE dot image collection from images. So we need to use this function. Okay, this is the function. So EE dot image collection from images. Suppose I have an image collection. So from this image collection, I create the another image collection. So I have an image collection 2809 image collection. Okay, so this image collection I need to convert 36 years image collection. So for that I need to use the function EE dot image collection from images. So I have some images, 2809 images. I want to convert another image collection, 36 years image collection. So let's go try to create this image collection. So take a variable. I put the variable name, suppose annual collection. Okay, and now we define this function EE dot image collection dot from images. So this function, because I have image collect, I have some images, so these images I want to convert into other collection. So let's use this function. So in this function I create a function. So this function helped me to filter every year from 1992 to 2025. Every year is filtering. Suppose 1990 it find out the 5 images and create the median composite. 1991 it find out the 3 images and create the median composite. So for filtering I create a function. So just we create a function. Suppose take the variable name, put the function keyword and put the element name. Suppose y. I put the y. Okay. So in this case, this y element indicating about the year. Suppose every year just come in this element or just put in this element and filter and find out images and create the median composite. So just I create a function and put the element name is the y, and what is my argument? So my argument is that I want to filter this image collection annually or year by year. Suppose 1990 all of image I want to filter. 1991 all of image I want to filter. 2025 up to 2025 all of image I want to filter and create the median composite. So for that create a variable, suppose annual equal, and I already have the image collection, full image collection. Just I call it because it stored 2809 images. Just call and paste here. So these things I want to filter. And how I can filter? I want to filter year by year. Suppose 1990, 1991, 1992 up to 2025 all of year I want to filter. So for that we simply use a function. It's called the EE dot filter dot calendar range. Okay, so this range will be year by year. So put here the y element and put the unit is the year. Okay, so this is the full collection. I just filter year by year, and after filtering what I do, I just create dot median composite. Okay, and further I just clip with my study area, which is AOY. So in this case, if you check what I do, I again explain. So I create a function. So this function help me just one by one this year come in this function and filter yearly. Suppose first year 1990 I find out the 5 images, it create the median composite. Then up to 2025 all of images and clip with our study area. So now how I can define the year? Okay, so for that we create a list. We just create a list all of years. So take a variable. Suppose I put the variable name is the years. So this variable I stored all of years between 1992 2025, all of years. So put here ee dot list dot sequence sequence and put the time start year and define the end year. So just I simply make the list all of it. So now when I connect the list with my function, what happened? One by one year just filter and create the median composite. So let's go try to print and check what happened. Just I comment all of line together and I want to print. So I will just print the list of years and run the code. If you check, we find the 36 and basically you can see 1992 up to 2025. Okay, this is the list of serial of years. So now we try to just connect this function. So and before that we also just return what I return from this function. So I want to return annual, this variable annual, set yearly. So set year and put here the y element. Okay, so now it's create a function. So in this function I simply connect with my list of year. So just I call the years, copy the variable and connect with this function, help of map function. Just put the map, start the bracket and also close the bracket. Okay, so now this is the function. It's help you to compute all of yearly median composite images. So if you check, just print the annual collection and run the code. We make a mistake in here. This mistake is that QA pixel did not match any band in our list. Okay, so because we are not defined the QA pixel band in our list, so we try to put the QA pixel. Okay, because all same band name. So just the new this band QA pixel because it's similar. So just write here this QA pixel. So now run the code. So now if you check 36 element, click on here, you can see it show the 7 bands. So all of year we find out the total 7 bands. So this is the image for 1990. Or click on here, this is the image for 1991 and up to 2025. Okay, we find out the image. It's the annual median composite image. So now I want to suppose display the image. Okay, I want to display the image. So for that, if you want, you can simply use here the map dot add layer and call the annual collection. And in the annual collection, suppose I want to display all of bands. So for that, just apply the two bands function, and run the code. So now in this layer, it added all of bands. We can easily add it in our map. If you check, suppose, so this is the image. So now just click on here and you can see 0 blue, 0 0 0 red. So if you click on here, you can see 0 basically first image, first year 1990. Okay, you can see. Then 1 mainly 1991, then 2 1993, and then up to you can see total 35 or 36 2025. Suppose I want to display the image in 1990. So put the suppose red band, then put the red green and put the blue band and stressing suppose 98% I keep. And another problem you can see, it show the digital number. Okay, it shows the digital number. So this digital number we need to convert into reflectance value. Okay, so I will show you after some time how we can do it. So now we find out the image in 1990. 1990, this is the image. But this number we need to convert into surface reflectance value. So how I can do it for converting? So I will show you that, then explain again, just a minute. So if you check the image collection in the Landsat surface reflectance, they provide the some scale value and also give the some offset value. So basically when I use this type of scale value and offset value, this reflectance value convert into this digital number, convert into reflectance value. So how I can converting or scaling? Okay, so let's go try to add the scaling and then rescale our image, then can get the idea. And if you check the all of bands are the similar scale and similar offset. Okay, all of bands for the Landsat 7, Landsat 8, Landsat 5 are the similar scale and similar offset value. So that's why I can simply use the one function. This function I can easily apply all of image collection. So check the Landsat 7 for the surface reflectance are the similar. Scale value and offset value are the similar. All the bands, but one bands have a problem. This band called the thermal band. If you check the thermal band, this is the STB6. Okay, this is the band name STB6 thermal band. And if you check the Landsat 8 and 9, this thermal band name is the STB10. STB10. This name is the STB10. So this is the only one band difference, STB10 and STB6. Basically Landsat 5 and 7, the thermal band name is STB6, and Landsat 8 and 9, the thermal band name is the STB10. Okay, so you can simply define it, because and if you check for the thermal band have the another scale value and offset value. You can see thermal band, this is the scale value and this is the offset value, another value. But all of optical bands are the similar scale and offset value. Only for the thermal band have the another scale and offset value. And scale and offset value are the similar all for the Landsat 8 and 9 also for the thermal band. Okay, so let's go try to rescaling our data. So this process basically it show the digital number. Okay, it's not the reflectance value. So we need the reflectance value in the remote sensing. So that's why we need to convert digital number to reflectance value. Use of scale and use of offset. So let's go try to do it. So I create another function in here. Again, we define the band name. Suppose this band Landsat 5 and Landsat 7. This band is the STB6. Okay, and for the Landsat 8 and Landsat 9, this band name is STB10. Okay, STB10. Basically this thermal band is neat when you work with the land surface temperature. Suppose you want to historical land surface temperature or